Hey everybody, welcome to a video on polynomial operations. We're going to do some adding, some subtracting. We're also going to do some multiplying and some binomial expansion. So adding and subtracting is something that you've been doing for a long time. It's just combining like terms. So when you add, all you're really doing is combining all of the terms, and you can actually get rid of the parentheses if you want to because it's just addition. So you look, go in descending order, of course. We have 5x cubes. And then we're going to look, we have an x squared, and we have a negative 2x squared. That's going to be a negative x squared. And then we have 3 x's and 5 more x's, so we have 8 x's. And we have a constant of a negative 4. So when you are adding, again, you're just combining like terms. When you're subtracting, you are also combining like terms. However, the minus sign is sometimes a little tricky. So one of the things you can do is change it to a plus sign, but then make that a negative x squared, positive 2x, and a negative 3. So all we did there is change the sign of everything on the inside, just to help with the whole negative part, so you're not subtracting a negative. So again, we have 2x squareds and a negative x squared, so that's going to be x squared. We have 3x and another 2x, so that's 5x's. And we have a negative 5 and a negative 3, so that gives us a negative 8. Okay? So adding and subtracting polynomials is just like combining like terms. Then we get to multiplying. When you multiply, this is where you can do it in multiple different ways. I'm going to show you 2 different ways to do it. One way is just ask yourself, what's 2x times 5x? And that would be 10x squared. And then 2x times a negative 2 is going to give you a negative 4x. And then you have to go use the other term. So we have to multiply a 3 times a 5x, which is going to give us a 15x. And then 3 times a negative 2, which is going to give us a negative 6. Then you combine all of your like terms, so you have 10x squared. And then these guys in the middle will combine to 11x. And then we have our minus 6. Now you might have heard of that as foiling, but I don't use foiling because it does not work for this, because we have a first, a middle, and a last of each term. So I don't like using a term called foiling. But there's another way that you can do this, and it also works for the first example. And what you do is you distribute. You take your first term, and then you take your second term, and your last term of the first group, and you distribute all of them into the same second term. So x squared minus 2x minus 8. And you just do it the same time, or the same equation 3 times. And then you distribute them all. So this one would give you x to the 4th minus 2x cubed minus 8x squared. And then you distribute this guy. That's going to give you 3x cubed minus 6x squared minus 24x. And finally, you do that with the constant. You have 2x squared, and then you have a negative 4x and a negative 16. So all we did is, instead of drawing a bunch of arrows to get lost, you just copy each one of those terms, and then you distribute it to the same one all 3 times. Now go back and combine your like terms. So you have an x to the 4th, and then you have a negative 2x cubed and a positive 3x cubed, so that's going to give you a positive x cubed. You have a negative 8x squared, a negative 6x squared, which is at negative 14x squared now, and then a positive 2, so that's a negative 12x squared. Negative 24x and negative 4x is a negative 28x, and of course our negative 16. So that's another way you can do it. Otherwise, you'll have to just draw a whole bunch of arrows. You can do it 1, 2, 3, then you do it again 1, 2, 3, but I just tried to eliminate all the arrow drawing. Choose whatever method you'd like. Number 5 and 6 is where I see a lot of people make silly mistakes. They just want to say, oh, cool, this is just going to be easy. All I have to do is say x squared minus 4. And I'll say, no, you're wrong. You're like, oh, yeah, -2 times a -2 is positive 4. No, you're still wrong. Because when you're squaring something, let's think about 6 squared. 6 squared is 6 times 6. So x minus 2 squared is x minus 2 times x minus 2. And then you would just multiply those out, and you would have x squared minus 2x, which would be a -4x, and then plus 4. So that's the big trick, is whenever you have a set of parentheses squared, or in this case cubed, you need to write it out and multiply it all out. So 2x plus 5 cubed means you're going to multiply 2x plus 5 times 2x plus 5, and then multiply that again by 2x plus 5. So it's going to create a lot more work. So over here, the first thing you might want to do is multiply the 2x plus 5 times the 2x plus 5. And when we do that, you're going to have 2x times 2x, which is going to give you 4x squared. And then 2x times 5, and then 5 times 2x is going to give you 20x, and 5 times 5 is 25. And now you have to multiply or distribute the singular terms as I showed you in the last problem, whatever makes you feel better. So you're going to have, when we multiply 2x to everything, you're going to have 8x cubed plus 40x squared plus 50x. Once you distribute the 5 into all three terms, you're going to have another 20x squared, 100x, and 125. Add those or combine all of those, and you end up with 8x cubed plus 60x squared plus 150x plus 125. So really all we did was multiply 2x plus 5 times itself twice. 2x plus 5 times 2x plus 5. And then you multiply that again by 2x plus 5. That's the same as saying 2 cubed. 2 cubed is 2 times 2 times 2, so you get 8, but when you're working with binomials, it's a lot more complicated. So wouldn't it be nice if we had a shortcut for number 6? And the answer is, there is one. Binomial expansion. Now, a guy by the name of Pascal came up with this triangle. And the way the triangle starts out with the number 1, and then below it you have 1, 1. But then as you work your way across, you add any numbers that's in between from the row above. So 1 plus 1 is 2. So right in between, you have a 2. And then you move on to the next row. So you start with the 1, but then in between the 1 and 2, you have 1 plus 2 is 3. In between 2 and 1, you have 3. And then, of course, you finish with a 1. Next row. 1 plus 3 would be 4. In between the 3 and the 3, 3 plus 6 would be, or 3 plus 3 would be 6. 3 plus 1 is 4. And then you finish with your 1. And this goes on forever and ever and ever. However, we're just going to stop at this last one. So 1 plus 4 would be 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then, of course, you finish with the 1. And what the binomial expansion means is we can FOIL out, multiply out, expand any binomial that's raised to the 0 power, which, of course, would be 1. All the way out to, a plus b raised to the 5th power, or in like the last example, 2x plus 5 cubed. And what you do is you just use Pascal's triangle to do that. So a plus b, and you have a 1 and a 1. That just means you have 1a plus 1b. Notice this has no b's, this has no a's. But now when you have it squared, you would start with 1. Now this is the term you're going to start with. You would have 1a squared. And then in the middle, you would have 2ab. And then you would finish with 1b squared. So what happens is as you increase from the front, you start with this exponent, so a squared, then you drop an exponent to a, then you drop an exponent and you have nothing. But working backwards, you start with the n, so you have b squared on the last term, b in the middle term, and no b on the first term. Okay? We'll do one more of these. So this one would give you 1a cubed plus, your next term is 3a squared b, and then you would have plus 3a, see we're going down one exponent per a, and this is b squared plus 1b cubed. Now that sounds like it's pretty complicated. But if you know how to use Pascal's triangle for binomial expansion, that 2x plus 5 cubed would make things a lot easier. So watch. 2x is a, and b is 5. So we would copy down the cubic. A plus b cubed is going to give us this pattern. So that means we have 1 times our a value cubed, so 2x cubed, plus 3 times our a value squared, so that would be 2x squared, times our b value, 5, plus, and now we're going to do 3 times just the a value, but then the b value squared, plus 1 times your b value cubed. So again, you could just multiply that out 3 times. But then, if you learn how to use Pascal's triangle, it'll go by a lot quicker. So you just have 1 times 2 cubed is 8, x cubed is x cubed, plus 2x squared would be 4x squared, and multiply that times 5, and you have 20 times 3, and you get 60 x squared. Over here, 5 squared is a 25, and 25 times 2x is 50x, times 3 would be 150x, plus 1 times 5 cubed is 125. So 8x cubed plus 60x squared plus 150x plus 125, and that sounds pretty familiar to me. So it's right there. Now, if you learn how to use Pascal's triangle, it'll save you a lot of time. So what if we were going to do x minus 2 raised to the 5th power? That means you would have to multiply x minus 2 times x minus 2, then multiply that by x minus 2 again, then multiply it by x minus 2 again, and then obviously one more time. You will end up with x to the 5th, x to the 4th, all the way on down. That's a lot of multiplying. So if you didn't appreciate Pascal's triangle the first time, let's take a look at it now. So we're going to use the 5th one. So again, x is our a, and a negative 2 is our b. So I'm going to skip down here for a minute just so we can write out the entire thing, but we have a to the 5th power. So we're just going to copy this down as Pascal's triangle rule. Plus, then we have 5 a to the 4th b plus 10 a to the 3rd power b squared plus 10 a squared b cubed plus 5 a b to the 4th plus 1 b to the 5th. Again, notice we start at a to the 5th, a to the 4th, a cubed, a squared, a to the 1st, a to the 0, which means he's gone. But you start with b to the 0, b to the 1st, b squared, b to the 3rd, b to the 4th, b to the 5th. Okay? So now you can go substitute every one of those terms in. So we have 1, and then a is x, so this is just going to be x to the 5th, plus 5 times our a value, which is x to the 4th, times b, which is a negative 2, plus 10 times a, which is x cubed, and then b squared, which is a negative 2 squared, plus 10 x squared, negative 2 cubed, plus. And I know it's going to take a little while, but ask yourself a question. What would you rather do? Multiply it out 5 times or take a shortcut? There you go. Lots of work. But now we just have to do it. We have x to the 5th plus 5 x to the 4th and a negative 2 would be a negative 10x to the 4th. And then we have 10, and we have a negative 2 squared, which would be 4. So that would be 40 x cubed. And then again, this is going to be negative 10 x squared. Negative 2 cubed is a negative 8. So negative 8 times 10 is a negative 80 x squared. We have negative 2 to the 4th power is 16 times 5 would be another 80 x, and then negative 2 to the 5th power would be a negative 32. So again, if you want to go multiply x minus 2 times itself 5 times, you go right ahead. But Pascal's triangle is a nice shortcut to when you have something to multiply out 4, 5, 6 times. Okay? That's it for this video. This is Longo, and I'm out. See you, bye.